Okay, in task 2.4 we are going to run a loop, and in this loop what we are trying to do is we are trying to output the contents of an array. So this is an array, right, and count is being used as an index, right. So this is our this count is basically being used to run our loop, and it is also being used as an index for the array. So we have an array called chars, right. We have an array called chars, and it has 4 boxes, right. I am assuming it has 4 boxes because this loop is going to run 4 times. So the first time the loop runs, the value of count is 1, right. The first time the loop runs, the value of count is 1. So we'll be accessing this element within the array, right. Then the next time the loop runs, we are going to be accessing this element because count equals 2. So we'll be pointing to this element within the array, and we're going to be outputting this element, right, this whatever is held in this location, right. And then the next time the loop runs, count becomes equals to 3. So now we'll be pointing at this location, and when count becomes equals to 4, we'll be pointing at this location. In our example, in this example, he has shown that chars is an array with 4 boxes, and there are ASCII codes stored within these 4 boxes. So this 72 is the ASCII code for H, 69 is the ASCII code for E, 76 is the ASCII code for L, and 80 is the ASCII code for P. So this is our array, which is basically holding characters inside, right. This array is holding characters inside, and it has 4 elements altogether. Okay. So through this code we are going to be outputting each character, right. So through this code we are going to be outputting each character on the screen, right. So let's get started. To get started, this is a for loop, right, and in for loop count is being given an initial value of 1. So that's the first step that we need to do. So we are going to set the value of accumulator to 1. This time we are going to use the immediate addressing instruction, in which we can pass a value. LDM uses immediate addressing, which means what? This value 1, which is our operand in this case, this value 1 is going to be directly loaded into the accumulator. So our accumulator will be loaded with this value 1. So this is not an address, this is a direct value. So we've used LDM, which is used for immediate addressing. Now we want to assign this value 1 to count, right, because we wanted to set count equals 1. For that reason, first we have loaded the accumulator with this value 1. Now we are going to store this value in the location that is labeled as count, right. So now we want to store this value 1 at this location count, so that the value of count becomes equals to 1. To do that, we are using the store instruction, and we are going to use the label count as our operand. So when this instruction gets executed, this value in the accumulator is going to be stored at this location. This value 1 is going to be stored at this location pointed to by this label count. Okay, once we have set count equals 1, now we can now what we want to do is we want to set our index register to 0. So we want to set our index register to 0 to move through the array, and you will see that once I write down my code. So once I've written down my code, this usage of index register is going to become obvious to you. So first thing that we need to do is we want to set this value of index register to 0. So because we have an absolute value with us, we can use the immediate addressing mode. To set the index register to 0, we can use LDR #0. Remember this hash sign. This hash sign means that we are using an absolute value, and the LDR instruction is used to load a number that is given in the instruction, which in this case is 0, to load that number into the index register. So this is the value that is going to be added to the this is the value that is going to be loaded into the index register. This is not an address, it's a value. How do we know it's a value? Because the hash sign has been given as part of the instruction. So what we've done here is that we have set the index register to 0, right? And now we are going to enter our loop. Now this is a precondition loop. Precondition means what? The condition is going to be this, so the comparison that we want to make, where we want to check the value of count, whether the value of count right now is within the range or not, because this loop is going to run as long as the value of count is between 1 and 4. What if the value of count is equal to 5, right? That is when this loop is going to stop. Okay, so that's the first thing that we are going to do as we enter our loop. We are going to load this value 5 into our accumulator. So what we are going to do is we are going to say LDM, because we are loading the exact value 5, right? So we are using immediate addressing. This hash sign indicates that we are using immediate addressing, that this 5 is a value and it is not an address, right? This hash sign is telling us that. So our accumulator will now have this value 5, right? Okay, once the accumulator has this value 5, so once this value 5 has been loaded in the accumulator, we can compare this value 5 with the value of count. So we are going to say CMP count, right? We are going to compare the value of count with the value that is already loaded in the accumulator. If the answer is true, if the value of count is equal to 5, if the value of count is equal to 5, then this loop is going to stop, right? Then we must end, right? So if the value of count is equal to 5, then we are going to, we need to come to this point, right? We need to end our program. So to do that, we are going to check. So we are going to say jump if the value of count equals 5, if this comparison is true, right? That is the comparison we are doing. So if the value, so if the result is equal, right? If count is equal to 5, jump if equals to end for, so that is where we are going to jump, right? To this label, right? And this is going to end our program, right? If the value, however, if the result is not equal, if the comparison is not equal, right? So let's say the value of count is 1 right now. So this jump is not going to be taken. If the value of count is 1 right now, this jump is not going to be taken. So what we need to do now is, now we have made sure that, you know, we can run this loop, because count has not become equal to 5, which means what? We are going to execute this instruction. Okay, what do we want to do? We want to load chars 1, because count is 1 right now. So we want to load chars 1 into the accumulator. And chars 1, by default, chars is pointing at this location. So chars is already pointing at this location, right? This is the label for this memory location, and this memory location by default is what? This is chars 1. So what we want to do is, we want to load this value which is stored in chars 1. We want to load this value into the accumulator, right? Because eventually what we want to do is, we want to output this character, we want to print this character, right? So here's what we are going to do. What we are going to do is, we are going to use LDX. Whenever we use arrays, we use indexed addressing, and the index value has been set to 0. So the address that is going to be calculated in this case, I'm going to write LDX chars. So this is my operand. The address in index register is calculated by adding the operand value, which in this case is a label, and this label is obviously pointing to some memory location. So so this memory location that is pointed to by chars plus the value held in the index register is the location that we want to go to, and from that location we want to fetch that value, which is going to be this value, right? Because index register is 0 right now. So when we are going to add chars to index register, that is going to be chars plus 0, and that is going to give us this location, right? This location. So we are going to go to this location, and we are going to load this value 72 into the accumulator, right? That is what LDX chars is going to do. So our accumulator value is going to be overwritten. It has 5 in it right now, and this is going to become what? This is going to become 72. So this is what LDX chars is going to do. Once we have loaded this value in the accumulator, now we can take our output, right? Now we can print this character on the screen, and the command to do that is The instruction to do that is out, right? Out is going to take this value in the accumulator and print its ASCII code on the screen, right? Then we have to increment our index register. Now to increment our index register, the command that we are going to use is increment, right? INC. Increment is a command in which the operand is always a register, right? That is what this table is telling us. In the increment command, the operand is always a register. So here we are going to specify the register name, which in this case is going to be IX, right? So here's what we are going to do. We are going to increment the index register, right? So the value of the index register is going to become what? 1. So now the value of index register has become 1. Now we want to increment count, because what we've done is we loaded this character into the accumulator, we've taken the output, we have incremented the index register. Now we must increment the value of count, and once we've incremented the value of count, eventually we are going to go back here and do this comparison once again to see if this loop is going to run the next time or not. So once we have done this output, we've already done this output. Now we want to increment count, and the value of count right now was what? The value of count was 1, right? So the value of this register count was 1 right now. So the value of this variable count was 1 right now. So count was holding this value 1, right? Okay. Now what we are going to do? Because we want to increment count, first we must load the value of count into the accumulator, because right now the accumulator has this value 72, right, which was the character that we just printed on the screen, right? This value 72 was loaded from our array. So what we want to do now is that we want to increment count. To increment count, first we are going to load count into the accumulator. So when we are going to load count into the accumulator, our accumulator value is going to be overwritten. It is going to become 1. So once we've loaded count into the accumulator, we are going to increment count. So now count is going to we are going to increment the accumulator, not count, right? We are going to increment the accumulator, and once we have incremented the accumulator, so this value of accumulator becomes 2, right? So this value of accumulator becomes 2 because we've incremented the accumulator. Now we can store this value back into count, right? Once we have, so we loaded count into the accumulator, then we incremented the accumulator, and this new value that we've reached after incrementing, we are going to store this value into count, right? So we are going to do what? We are going to call store count. So this new value 2 is going to be stored in this memory location count, right? So the previous value 1 is going to be overwritten. So this value 1 is going to be overwritten, and this new value 2 is going to be stored into count, right? Okay, so now that the value of count has been stored, we need to go back up, right? Because we need to check once again whether this loop can run or not. So we are going to jump. This time there is no comparison, right? If we are doing a comparison in the previous instruction, like if we were doing a comparison here, for example, then we have two options. We can use jump if equals to, or jump if not equals to. Following a comparison, these are the two instructions that can be executed, right? But if we don't have a comparison, then we can simply do what? We can simply call the jump instruction, and the jump instruction, this time we are saying that you have to jump to this place, loop, right? Go back to this instruction, loop, right? So go back to this label, and we're going to go back to this label. Once again 5 is going to be loaded into the accumulator, LDM #5. This is the instruction that is going to be executed. The value of count, which is 2 right now, which is where is count? So value of count is 2 right now. So this 2 is going to be compared with this value 5, right? This is what we are doing in this comparison. If the result of this comparison is true, if 5 equals count, then we are going to execute this instruction, jump if equals to end 4. So this instruction will only be executed if this comparison that we are doing on this line is going to give us a true value. Only if this jump, so this jump equals is only going to be executed if this comparison proves to be true. If 5 is compared to count and the result is true, only then jump equals gets executed, right? So the value of count right now is 2 and it is not equal to 5, so this instruction will not be executed. So what are we going to do? We are going to load chars, right? And we are going to do that using index addressing, right? And chars is now going to be added to the index register value, which is what? Which is 1, right? We incremented the index register last time we ran this loop, right? We incremented this index register last time we ran the loop. So this time the effective address is going to be chars plus 1. Chars plus 1 will be what? This location is chars. When we add 1 to it, we reach this location, right? So index register had this value 1, right? And chars was pointing right here. So when we do chars plus 1, we end up on this location. So once we have ended up on this location, right, and we are doing load, right, LDX is what? This is indexed addressing. So this value which is held at this location, right, this value which is held at this location, right, because this is the address that we've calculated, chars plus 1, right? So this is the address that we've calculated. This value 69 is now going to be loaded into the accumulator. So our accumulator will now be, its value is going to be updated to 69, right? Okay. So once this value has been uploaded, once we've loaded this value into the accumulator, we are going to output, then we are going to increment index. Index is now going to become 2 instead of 1. Then we are going to load the value of count into the accumulator. So the present value of count is what? 2. So our accumulator will now be uploaded with this value 2, right? Once the accumulator has been uploaded with the value of count, we are going to increment the accumulator. And so now the value inside the accumulator will become 3 instead of 2 because the accumulator is being incremented. So this value is going to become 3 instead of 2, right? So this value is going to become 3, right? And then we are going to store this new value of the accumulator into count, right? So this value here in count, this value instead of 2, this is going to become what? This is going to become 3, right? So we're going to have 3 here. Once that has been done, we are going to jump back all the way to loop, right? This is where we're jumping. We are jumping to this label. So we're going to come back here, right? We're going to come back here. Okay, this is getting very messy. Let me clean this up. Okay, once again, so this is where we've jumped up to, right? From here, from this point, we've jumped back up to, okay, so from here we are going to jump back all the way back to this loop, right? Once again we are going to load this value 5 into the accumulator. Once again we are going to do the comparison with count, and count is equal to what? Count is equal to 3 right now. So this loop is going to run again because you know, count has still not reached 5. So this will not be executed because the result of this comparison is going to be false, right? And so this jump if equals will not be executed. We are going to load the value from the array using index addressing. The index value right now is 2. So chars plus 2 is going to be the new address, which is what? Chars is here right now, right? Chars is here, right? So this is chars, right? So this is chars, this location. Let me just clean this up. It's too messy, right? So this is where chars is right now. This is where chars is, right? And when we add 2 to it, chars plus 2 gives us this location, right? Chars plus 2 gives us this location. So this value is going to be loaded into the accumulator, right? Once this value is loaded into the accumulator, we are going to carry out the out instruction. So this is going to print the corresponding character. Then the index value is going to be incremented. Index right now was what? Index was 2. So now index is going to become 3, right? So then we are going to what? Load the value of count in the accumulator, and the value of count is what? 3. This value of count is loaded into the accumulator, and then we are going to increment count. Sorry, we are going to increment the accumulator, right? So this value 3 is now going to become 4, and this new value 4 is going to be stored into count, and then we are going to jump back up, right? And this time when we do the comparison, count is equal to 4 right now. So when we compare 4 with 5, the answer is going to be false. So once again this loop is going to run, but this is going to be the final time that this loop runs, and when this loop runs the final time, this is going to be output, right? This is going to be output. This last character here is going to be output, and finally we are going to increment. So finally when we are going to load count, we are going to increment the accumulator and store this new value of count. Then count is going to become equal to 5, right? This final time count becomes equals to 5. So when we go back and jump, right, this time this 5 will be compared to count, which is equal to 5. So 5 will be compared to 5. The answer is going to be true, and this instruction says what? Jump if the comparison is true, jump if the comparison is equal. And this time the comparison was equal, 5 was equal to 5, so we are going to jump from here direct to end for, and this is where the program is going to end.